Hi everyone, and welcome to our video on measurement and significant figures. So the first thing we'll talk about here is how many digits do we need to write down when we're taking a measurement. Now, the easiest tool to use is a digital measurement tool because you just write down the numbers that you see. So if you were given this situation here where you have 2.93, that number right there, that's just what you would write down in your paper or whatever. Now, if you're doing an analog measurement, that's a little bit different. What you want to do is you want to write down all the numbers that you're certain of and then one that is uncertain or one that is an estimate. So we come down here, we see 8.52, right? That number is, probably shouldn't cover it up like that. Let me erase that a little bit. But that measurement is two numbers there that we are very confident about. So we know that there's an 8, we know that there's a 4, and then the 2, like right here, we're pretty sure that that's a 2. So that's our estimate. Now we could take that same measurement over here, and we know that there's an 8, but the 4, that's kind of our estimate. The 2 is definitely not something that we can say with any certainty. The 4 is our number there that is uncertain in our estimate, and we would stop there. So that's one thing that you want to look for when you're taking your measurements is look out for what are the numbers that you're certain of, and then have one number that is uncertain or an estimate. Okay, now this page is a little bit busy, but let's go over all these rules here. Some of them are kind of easier than others. So the first rule that we have here, so we have this first rule, which is that any number that is not 0 is significant. So if we have 34.5, those numbers are significant. So we have 3 significant digits. Zeros that are between non-zeros, those are also significant. So that one might be kind of easy. So all these numbers are significant. So we'd say that this number is 4 significant figures. Leading zeros to the left, are not significant. So all these zeros here don't really count. The only number that's significant is this 4. So that's one significant figure. And hopefully that kind of makes sense. Once we talk about like scientific notation, I could easily write this number in scientific notation and it would only have one digit, and that would be this 4 right here. Okay, and then the last one that gets a little bit tricky is trailing zeros. Trailing zeros may or may not be significant. It kind of depends on the situation. The easiest way to let people know that these digits are significant is by including a decimal point. So this number here, 410, that is only 2 significant digits, the 4 and the 1, but the 0 might not be significant. I mean, you can imagine a much bigger number like 5 million. That only has 1 significant digit, right? All the zeros are really just like estimates, and we don't know where the significant figures stop or start. Now, when we include a decimal, though, we're letting people know like these are my significant digits. I am saying that my measurement is really precise, that I've took my measurement. I'm confident in these first 3 numbers. And then the 0 here is my number that I'm estimating, but all those are significant. So we'd say this one has 4 significant digits. All right, when it comes to calculations for multiplying and dividing, the answer should be rounded to have the same number of significant figures as a number with the fewest significant figures. So for example, let's say we have a person and they are running, let's say they run like 45 meters. Okay. And they do it in we have a stopwatch and our stopwatch says 6.47 seconds. And let's say we want to know how fast are they going? What is their velocity or what is their speed? We'll talk more about velocity and speed eventually. Long story short is you just take these numbers and you just divide them. Okay, and I could put that into a calculator and I'll do that really quickly here. And the answer I get is 6.955117, and it goes on and on and on and on. Okay, so I see many students write this down and they ask me like, how many decimal points should I include? Well, really you should look at your digits from your values that you were given and say, okay, which one has the lowest significant figures? The one with the lowest significant figures is the 45, right? The 45 only has 2 significant digits. So because it only has 2 significant digits, I'm just going to write SF for significant figures. Because it only has 2, then we need to round this number. And we could round it. Well, I think our best estimate, we have to pretty much just look at these numbers here and say 6.95. Well, I'd round the 5 up and just call this 7.0. And it's meters per second. And that's where we would stop. So this is as confident as I could be in my answer. All right, I can't be this confident. I can't be that confident. This is the real answer here. Okay. Now for adding and subtracting, it's a little bit different. We have to look at decimal places. So if I'm adding up numbers, let's say I have a couple of masses here, and let's say I have a mass of 45.2 grams. And then I look at my numbers and I have another measurement that's 43.15 grams. Okay. And if I was going to add these up, right, it'd be easy to say, okay, well, then my actual mass is just these added together. But if we're using significant figures, that's not quite right. What I should really write down is 88.4. Let me make sure. I might have to do that a little bit cleaner. Okay. Make sure we don't have any extra decimal places here. Okay. But that's kind of what it should look like. So because I have a number here that only has one decimal place, then that is as much as I can do for my digits, right? This only has one decimal place, therefore my answer should only have one decimal place.